Hello, folks. As always, you're going to need to read the questions very closely and keep track of the number of marks. This is a 1 mark question, about 90 seconds. This is a 2 mark question, about 3 minutes. The standardized sodium hydroxide solution from C was used to titrate a propanoic acid solution of unknown concentration. Calculate the concentration of the propanoic acid if 15 centimeters cubed of its solution was neutralized with 20 centimeters cubed of standardized sodium hydroxide. If you did not determine the concentration of sodium hydroxide in part C, use 0.2155 mole per decimeter cubed, although this is not the correct answer. Now remember, as I have said before, you can always assume a number if you don't have one. Okay, now all of that said, let's go back and find the concentration of the standardized sodium hydroxide solution from C. If you were doing the question, of course, you would have it immediately above. We did it a few videos ago. So the standardized concentration was 0.2490 moles per decimeter cubed sodium hydroxide. All right, now I'm going to work the theory of this over here on the right-hand side. So my sodium hydroxide, I've got 0.2490 moles per decimeter cubed is the concentration. And I know from the question itself that I am using 20 centimeters cubed of the sodium hydroxide. So I have my concentration and I have my volume, 20 centimeters cubed. Now I'm going to go ahead and write that as 0.02, how many significant digits? 400 decimeters cubed of sodium hydroxide. Then I've got my propanoic acid. Now, if you've done the whole syllabus at this point, then you know that prop means 3. 1, 2, 3 carbons. It's anoic acid, so it's C double bond O, OH, and then that's CH3, and that's CH2. Now, that does not matter in the least for this particular problem, because what we generally do with acid-base problems is we simply abbreviate HA. Okay? So I'm just going to keep that HA as propanoic acid. So my propanoic acid is going to be some unknown concentration. I do not know what it is, but I do know that it was 15 centimeters cubed. I'm going to go ahead and put that in decimeters cubed, 0.01500 decimeters cubed. All right, now at this point you need to make sure that you understand what the stoichiometry of this thing is. Now in the syllabus they are almost always going to give you what are called monoprotic acids. It's only a single acidic hydrogen. So if you do not have time to think about it, right, then I would always assume that you're going to have a 1-to-1 ratio between the sodium hydroxide and the acid. Okay, they're going to give you a monoprotic acid. It's going to be a 1-to-1 ratio. Okay, now if you're the kind of person who just can't be satisfied with that, then the actual equation is going to be propanoic acid plus sodium hydroxide is going to make water plus sodium propanoate. And it is, in fact, a 1-to-1 ratio. Okay, now, what does that do for you? What it does for you is it says, essentially, if I can take this sodium hydroxide and I can turn that into a number of moles, then that number of moles of sodium hydroxide is also equal to the number of moles of propanoic acid, right? So then, once I know that number of moles of propanoic acid, let's try that again. I can use that to figure out the concentration of propanoic acid. All right, so that's the general idea. So what we're going to do is now generally I would teach my students to do this in 2 steps. I would first do the moles of the sodium hydroxide, then I would translate that into the concentration of the acid. You don't have to, you can do it at one time, but that is the way I'm going to show it. All right, so the number of moles of sodium hydroxide is equal to the number of moles of propanoic acid. Now you do not have to put this. I am putting this here because this is an instructional video. Now we know that the formula is moles is equal to concentration times volume. So the concentration of the sodium hydroxide was 0.2490 moles per decimeter cubed, and the volume was 0.02000 decimeters cubed. Those cancel, leaves us with moles. Again, you don't necessarily have to use the units when you're working, but I always counsel people to do so because a lot of times it will help you catch errors. Now, this will be 0.00498. In actual fact, it will be 4980 because that has 4 sig figs and that has 4 sig figs, but they're not going to count off if you don't do that in the middle of the problem. So this is going to be your moles of propanoic acid. My concentration of propanoic acid is therefore going to be moles divided by volume. So concentration of propanoic acid is going to be 0.00498 divided by the volume, which was that, but translated to decimeters cubed, 0.01500 decimeters cubed. So then we're going to do the math on that, and we're going to get 0.332, but every single thing in this whole problem is 4 significant figures. And so I'm going to put the significant figure right there, which is a 0. Now, is that going to be on the mark scheme? I don't know. But here's the thing. You don't know either. So keep track of your sig figs as you go would be my best advice. Okay, so let's check the mark scheme on that. That is exactly right. Okay. Now, in the mark scheme, they use the centimeters cubed. Okay. They don't translate it to decimeters cubed simply because this one right here is on the bottom and that one right there is on the top. So you end up with this kind of situation. And the centimeters cubed cancel out. All right. That's fine if you understand how the math works, but I always counsel my own students to change things to decimeters cubed because that is the definition. All right. And then, of course, it gives you the answer if you use the alternative 0.2155. Notice there are no marks here for significant figures. All right. But that's the way it goes. Okay. Now, this particular one is actually a very simple question, but it's one that most students, well, I won't say most, a lot of students will struggle with because they don't quite realize how simple it is, and in fact, many people will skip it. You see that in the exam reports a lot. Okay, so Determine the pH of the propanoic acid from F1, that's here. Propanoic acid has a pKa of 4.87, and then they tell you what concentration to use if you did not get that correct. All right, now we're going to do the calculation for this thing, but I'm actually going to show you the theory behind it as we go. All this is propanoic acid, okay? HA, right? So, given that it's just HA, what's going to happen is it's going to dissociate into H plus and A minus. Now, you saw these, you've used these ice tables before, I'm sure. You don't have to use these to solve this problem, but this is the theory behind it. So I'm going to have 0.3320 molar here. Initially, I'm going to have none of that and none of that. What's going to happen is it's going to dissociate. It's an equilibrium. So because there's plenty of this and there's none of these, the equilibrium is going to shift in the right direction. Because of that, you're going to lose HA. Any HA that you lose is going to show up as H plus and A minus. So at the end, or at equilibrium, you'll have 0.3320 minus X and X and X. Now, remember from your equilibrium studies that Ka is going to be equal to your products over your reactants, because Ka is going to be concentration of hydrogen times the concentration of the propanoate divided by the propanoic acid. You're going to end up with this equation. Ka is equal to, we take the X and we put it in there. We take that X, we put it in there. We end up with X squared. Then we take this and we put it down here. We end up with 0.332 minus X. Now, the theory behind what I'm about to do is that this X is very small compared to this number, okay? So we would say 0.332 is much, much bigger than X. The word for that, we call that negligible, all right? But if you want to cheat a little bit, basically it boils down to this. The IB says you will not use quadratic equations. So therefore, you can approximate that as 0, okay? Because the IB is telling you no quadratics. All right? And if you put this in there, you're going to have a quadratic. So now, I'm going to take this equation right here, I'm going to bring it down here, and I'm going to finish working it, and then we're going to do the calculation. All right, so if I take this bit here, okay, I end up with X squared over 0.332 is equal to Ka. Well, what's Ka? Well, they told you pKa was negative 4.87. P is always negative log. So pKa is the negative log of 4.87. Well, that's pKa. Oh, excuse me. Let me back up. I messed that up a little bit. So 4.87, I'm sorry, is equal to the negative log of the Ka. So therefore, to get the Ka, I simply take Ka is equal to 10 raised to the power of negative 4.87. Right? So that's my Ka. Now, if I do that on my calculator, 10 raised to the power of negative 4.87, I'm going to get 1.3489, so 349 times 10 to the negative 5. Okay? And then that is going to give me that equation. They said you want the pH, right? So in order to get the pH, you need to calculate the H+. Well, recall this right here, this X, that X is H+. So basically, we need to solve for X. So that's what we're going to do. X is equal to 1.349 times 10 to the negative 5th times 0.3320. But it's x squared, right? So if I take the square root of both sides, then I end up with the square root of that is equal to the square root of that. So I end up with x is equal to, right? And I'm going to do this bit actually up in the problem, because this is what would show up on the problem. X is equal to the concentration of hydronium is equal to the square root of 1.349 times 10 to the negative 5th, that's the Ka, times 0.3320, that's the concentration of the propanoic acid, and then I'm going to do that in my calculator. So, square root, parentheses, 1.349 EE, negative 5 times 0.332, close parentheses, enter. And I get a hydronium concentration of 2.116 times 10 to the negative 3 moles per decimeter cubed. Now, that doesn't get me the pH, of course, because remember, pH is the negative log of the hydronium. So, pH is going to be equal to the negative log of 2.116 times 10 to the negative 3. All right, so negative log answer, and I get a pH of 2.67, which makes sense because it is propanoic acid, by the way, so the pH should be less than 7, and that makes some amount of sense. Let's check our mark scheme. And of course, that is exactly right. So there is your square root, right? That gives us the molarity of the hydrogen, and then that gave us the pH. And they do say award 2 for the correct final answer. So if you did all this on your calculator and then punched it in, you would get it. I recommend leaving a bit more of a trail than that, but you could do that.